Okay, we'll get started. Okay, so first off, apologies for the quick cancellation last week. My son broke his arm. It's fine. He has a cast now, and will be good in 4 to 6 weeks. All right, so last week, then you would have watched the video. One of the things that's covered in the video is the assignment. The assignment is due next week, Wednesday, I think. Let's see. I don't know why they're on a Wednesday. I just copied, I think, from last year or something. But yeah. So anyways, I wanted to just see if there were any questions, because obviously last week you wouldn't have had a chance to ask me about it. It's all pretty straightforward. Are the blank looks because you didn't realize there was the assignment? It could be that no one watched the video. So it is, I can go over it if people need it. But yeah, okay. So basically what you're going to do is do an evaluation framework. And you're going to compare 3 systems for ticketing. Ticket, like say you go to a concert, a sport event, or something like that. There's different ways of doing tickets. There's different kind of security properties you want to achieve. For example, like the ticket holder actually owns the ticket. If I sell my ticket to someone else, I'm not selling 2 copies to 2 different people. And so anyway, so there's different ways that you might tie the ticket to the person who holds the ticket. So you can read the 3, or just watch the lecture from last week, because I do go through it in detail. But there's basically one where it's just based on the paper. So as long as the paper is good, then it's okay. There's some e-ticketing systems where it's digital. And then there's some where it's like kind of tied to your actual identity. So there's like a database with like the name of the person and then the ticket. And then when you show up, you're going to show an ID as well as the ticket. And so these things are going to solve different problems. None of them are good solutions. They're not like a perfect solution. Like some of them are technically more complicated. And so the idea is to use an evaluation framework to study what the trade-offs are between them. Okay? So the first question concerns stride. So basically what you'll do is you'll start with S for spoofing. Then you go to tampering, then you go to repudiation. Let's see. Okay, so you'll start with the physical system, and you'll do spoofing, and you'll just say, are there spoofing attacks, yes or no? If there are, what are they? If there are attacks, what does it do to mitigate them? Okay, so you might say, well, it's printed on a piece of paper, and the paper is like hard to forge. If I printed off a ticket that looked the same, it would be on a different piece of paper. So like that's the spoofing. The spoofing attack is I'm going to create a forgery of this physical ticket, and then the countermeasure would be like the paper that's printed on, or there's a hologram on it or something like that. Now, what I can say is you can make assumptions. So these descriptions are meant to be very minimal. Okay, they just give you enough detail that you can tell the difference between them, but you can make whatever assumption you want. So you could say, well, I assume that there's a hologram on it, or I assume whatever you've seen in real life, that's okay. So as long as what your evaluation is consistent with the assumptions that you're making, the TA will take that into account. Okay, and then what you can do is you can quickly say, in e-ticketing, is it the same or is it different? So you might say, well, for spoofing, it's different because there's no ticket anymore, right? So if it's different, then you can say why it's different. But for a lot of them, you'll just say it's the same. It's the same attack. Doesn't matter whether it's a physical ticket, an e-ticket, or an online system. Okay? So read this paragraph. It says, 1 sentence about this, 1 sentence about this, 2 sentences about this, and just make sure that you follow it. But what you're going to do is you're just going to come up with attacks walking through stride for ticketing systems. Then what you'll do is you'll build an evaluation framework. Okay, so for evaluation framework, we want usability properties, we want deployability properties, we want security properties. So the first thing you'll do is come up with what those properties are. Okay, so what the columns of the evaluation framework will be. I want 6 of each. 6 on security, 6 in usability, 6 in deployability. For each column, you need to say what it's called, okay? Remember to phrase it positively from the lecture. You have to say, what does it mean to get a full dot, and what does it mean to not get the dot? If you want to use a half dot, that's fine too. So that's up to you. You can do it with or without, depending on what you think. So it's up to your judgment. And when you come up with your security requirements, you know, in the first question when you're going through Stride, you came up with a bunch of attacks and countermeasures and things like that. You can reuse anything you did there in your security columns. That's fine. Okay, and then finally, you're going to evaluate the system according to your columns. And just to save time, I'm not going to make you evaluate all 3. You'll evaluate just the online system. Okay, so you can do 1 row of just the online system, and you'll just walk through and say, okay, for my security column 1, I'm giving a full dot, and then just 1 sentence of why. Why is that a full dot as opposed to a no dot or a half dot? Okay. You don't have to put it in a table. It can just be like a bullet list where you're just like, here's the column, and then this is the dot I'm giving it, and then this is the reason. Okay. If you want to put it in a table, that's fine. So graphically, it can just be a sort of list. Okay. So that was a brief overview. As I mentioned at the end of last lecture on the recording, I go through it in more detail. But given that, are there other aspects that are unclear? Is this coming too fast? I know it was kind of weird because of last week. You know, you can have an extra week to do it if you want. Yeah? Okay. All right. So I'll update that in a second. So you can do it next Wednesday. Okay. So then that will give us. You'll have another lecture to ask me questions. So if you haven't seen it, go through last week's recording, okay, and then go through the assignment, and then you really have to come with the questions next week because you only have half a week to finish it. But you should have enough to do it. It's not the kind of assignment it's not hard in the sense that it's not technical. The difficulty is actually creating the columns, like you'll come up with 4 deployability things, just like 1, 2, 3, 4, and then you'll really struggle for the 5th or the 6th. So that's like sort of where the work goes into this. It's just like trying to come up with these things. Yep.
Where did you get that from?
Sure. So the one in the lecture we do in the lecture itself. So you'll see me we're going to walk through and actually do it dot by dot. What it is it's a toy example of a framework that's from this paper. So this paper is on the Moodle, and this is like what I talk about it in the lecture too. At the end, but this is like what a full-fledged evaluation framework published at the very top security conference would look like. Okay, so what we do in class is kind of a toy, right? This paper is like the most formal that you could do it. And then what I'm expecting for your assignment is in between, like a little more formal than what we did in class, but closer to what we did in class as opposed to this. Now, if you might decide you like these evaluation frameworks, I'm going to do one for my project, right? In that case, I like something closer to the academic paper. Okay, so like a more formal type of thing. So it's one thing that usually every year there's a bunch of students that do evaluation frameworks of various things. It's one of the projects that, I see a lot. But you need to do it like very, very formally if you're going to do it for a project. Yes? Yeah. Is there like a specific piece of it that's confusing, or?
Yeah, I mean, to some extent, Stride has spoken is a bit straightforward. Like, there's a framework for evaluation. Like you rightly said, we need to create a category for us to do that. So eventually, we need to come up with what the evaluation policy like.
Exactly.
So that's what I mean. So, I mean, it's not like there's a framework. You need to think of how to develop this framework.
Yeah, exactly. So that's the challenge of the assignment, or that's where the work is. So you're going to have to sit and think about What are 6 usability things that people would be concerned of with the ticketing system? And what are 6 security things? And what are 6 deployability? So you can use, so I give a bunch of examples. I think at the end of the assignment, there's a bunch of papers. Now these evaluation frameworks are not about ticketing systems, right? But they show you, like passwords and ticketing systems, there is some overlap, right? Like there are going to be some columns from that paper that do apply to ticketing, and there's going to be a bunch that don't. But when you go through it and look at it, it might give you ideas. Like they start talking about like the cost of servers, and you're like, okay, well in a ticketing system, like if it's paper, I don't need a server, but if it's online, I need a server, so that's a cost. But if it's paper, I have to print them out, so that's a different kind of cost. Like, and so you can sort of, yeah.
There's no security around what you said, because it's basically two different things. Because if I need to buy a server is just like something that processes the whole system. So essentially, the security now is like the whole process, and the server is like part of the system. Exactly. So that's when, because we need to find a middle ground between the two.
You mean between the different ticketing systems or between the different columns?
Well, maybe between the system.
Yeah, okay, so like, just like take one big step back from the evaluation framework. Why are we doing this exercise in the first place? So the answer is that like like whatever, Bell Center or whatever, they're like, we have to do something for ticketing, right? We have these 3 ideas, which one's best, right? So any difference, if I'm like, you can do this, but you have to spend $200,000 on servers. You might say, for me, that's not the best, right? Or you might say, we're rich, we don't care. You know, if that saves us something else, or if that helps with security or helps with scalping, we'll spend the $200,000, right? So everyone will look at the table differently. Like the table doesn't tell you that one of them is best. It just sort of tries to communicate like what the trade-offs are, and then different people will decide which one's best for them. Yeah. So there's no like judgment built into the table. Yeah. Okay. Other questions or comments? Yeah.
This summit is a bit, like I said, it's on a smaller version. But when we go on a larger version, is there like a common practice to ensure that I'm not repeating myself?
Like you don't have columns that are the same.
Yeah.
So,
or is it like just based on personal belief and?
okay, so it's sort of a combination, I guess. So the telltale sign that you're repeating yourself would be that actually you have 2 columns where the dots are exactly the same. So if you don't see that, that's an indication. The other thing you might sometimes see is the flip. So you might see that every time it gets a full dot on column A, it always gets no dot on column B and vice versa. And so those may be like interconnected properties. Like once you have one, you can't have the other or vice versa. So if you see patterns like that, you need to start thinking deeply about whether they're the same thing or not. I think if I recall from the lecture, there is an example where the columns come out the same, but we decided that they weren't the same property. So yeah, it is very subjective. It's just based on your rationale. And the fun thing about this assignment is, you know, there's 100 students in the class, and you're all going to come up with different columns and even different dots for the same style columns and things like that. Like there'll be a lot of overlap, but like if you give the exact same assignment to 100 people, they're all going to come up with different stuff. Yeah. And so it's not scientific in the sense that everyone's going to have the same table at the end. Yeah. Okay, other questions about the assignment? No. Okay. All right, yeah, so take a look at it, and I'll actually, maybe I'll just extend it now before I forget. So 12th is next Wednesday? The other thing I didn't mention, but I'm sure I mentioned in the video, is you have a slip day as well. So if you want to hand anything in late, you can do it on one of the two assignments, so you can choose. So if you use it for assignment 1, then you have to hand in assignment 2 on time. And if you want to hand in assignment 1 on time, then you can slip on assignment 2. Slip means that you have 2 extra days to complete it. You don't have to email me or tell me that you're using the slip day or anything like that. We'll just, when Moodle collects the assignments, it timestamps when it comes in. And so, yeah, we'll keep track of which assignments you use the slip days for. Okay. Another thing too is there is a time cutoff. Every year, like someone, I don't know, something happens and you submit 5 minutes late and you're sending an email, like I'm going to accept it. I don't care about 5 minutes here, or an hour there, kind of thing. So get it in roughly on time, but we're not like going down to like nickel and dime on the exact minute that it comes in or things like that. Okay, that's all I want to say about the assignment. Are there other questions? Okay, good. Okay, so we'll go into the lecture. This year, I'm going to do something slightly different. I reordered the lecture. So in the evaluation framework, so in the video that hopefully you've watched, and if you haven't, you really should watch it. You'll need to watch it for the assignment. I'll just show you one slide from it. So the evaluation framework, we're looking at usability, we're looking at deployability, and we're looking at security. So one thing I'd like to cover in the class is how do you figure out the usability side of things? So security, you'll take lots of courses where you learn different security methods and you're in your projects and things like that. It's probably a little less clear. It's not covered in any of the courses. How do you decide if a system is usable or not? Okay. So what we'll do is this lecture, I'll go through the theory of how you determine that. So how do you do an evaluation of the usability of a secure system? And then next class, what I'll do is I'll give you an example. So we'll study Tor, which is an anonymous browsing tool. And we'll do an actual, what's called a cognitive walkthrough of that software. And then in assignment 2, it won't be due for like a month. But in assignment 2, you'll do a cognitive walkthrough for that assignment. So part of the reason I pushed this up in the course was just so that you could start doing your assignments earlier, because last year you kind of had to wait till we covered it in the course, and then there was only like 2 weeks left, and it's kind of a busy time at the end of the year. So anyways, that's the sort of motivation for pushing it up. Okay, so we'll talk about usability for 2 lectures, and then we'll go back to the high-level methodologies. So we talked about STRIDE, we talked about evaluation frameworks, and we'll go into a third high-level methodology called attack trees. All right, let me fix them while I'm here. So this will be lecture 3 and 4 now. Okay, so let's say that I come to you and say, I have this great security tool, 2-factor authentication or something like that. And it's really good because it actually adds security. And now if you forget your password or someone steals your password or there's, I don't know, a keystroke logger on your computer or something like that, now you can still log in and you won't get attacked. Okay, so that's great, right? But what happens if it's not actually usable? What if users hate using it, right? What if they make mistakes using it? What's sort of the end result of that? And so the first thing is you're going to frustrate your users, right? They don't like using the system. They hate it. They are always making mistakes. It's wasting time. Maybe they're your employees at a company, and so it's like hurting productivity. Users will try to avoid it. So sometimes you can and sometimes you can't, right? But you might find different ways of doing it, right? Like, for example, I don't know, I don't like the Wi-Fi at Concordia for some security reasons, so I'm always going to like tether to my phone because then I can do what I want, but that's not good for the enterprise because now my traffic isn't going through Concordia, it's going through an external thing, right? And so Sometimes, or like say there's a bunch of software, like it's remote management tools and stuff on my computer, and I get frustrated because like things are breaking, and when I try and do updates, it's not letting me. So I just disable it, right? I just turn it off. When it pings me, when it tries to ping Concordia server for the remote management, I just send it to the trash bin on my computer. I just redirect the traffic. And so it never leaves the computer, and then my computer, like, it kind of complains a bit, like I can't connect to this remote thing, but I just dismiss those errors, and then I just proceed without having any remote management, okay? So if users really hate it, and there is a way to avoid it, then they will avoid it. And when they avoid it, they might be even less secure than they were before you introduced the tool. So in a sense, if you have bad usability, it can actually make the security of the whole thing, the effective security of everything, worse than it was when you started, okay? So this is why, even though usability is not the same as security, it has to go side by side, okay? If you're going to do security, you have to do usability at the same time in order to make sure that you're not just increasing security, but people are going to want to use it. Another thing just about security is it's usually it's not their first goal, right? I don't sit at my computer and say, I really want to be secure today, right? I want to go on the web, and my main goal is to be secure, right? And then my secondary goal is I want to, figure out who won the soccer game last night, right? No, I want to find out who won the soccer game. That's my first goal. And if I can do it in a secure manner as opposed to an insecure, then great. Okay? So it's a consideration for me, but it's my secondary goal. It's not my primary goal. So my primary goal is to actually get some task done. Okay? And so just as to sort of preview, when we talk about how we evaluate usability, we're going to come back to this idea that everyone just wants to do tasks. Okay? And so when we evaluate it, what we'll do is we'll actually pick tasks that users want to do, and that's how we're going to go about evaluating the system. But you'll see that in a bit. Another sort of problem is that users fatigue and habituate to warnings and errors, meaning the first time you show users an error, they've never seen it before, they take it very seriously, right? They read it, they think about it, like, okay, what does this mean? Should I do it? Right? But the 10th time they see it, the 100th time, they're not even thinking about it. They don't even know that it happened. They click okay so quickly that it doesn't even register that it happened. Okay. So security works best when it's in the background, you have some policies on your computer or some automated, tooling or whatever, and it just makes the most secure decision for you. That's the best approach. The secondary approach is that you're bugging the user all the time, right? Like you just saw something, what do you want to do? You saw a certificate, it's bad. You can go to the website if you want to, right? Or you can choose not to because it might be an attack. I don't know, I just see it's bad. I don't know, like I'm the computer, I don't know whether it's actually an attack or not, right? So you decide, right? And then you give the user a warning, and then they have to think about it and click through, right? And so those are the kinds of things that sometimes the designers of systems, they think it's good because it's empowering users. But by empowering the users, you're also just sort of confusing them and sometimes making them, just try to swat away the message as opposed to actually react to it. So it might be better for you to just handle it yourself and do your best guess of what the user should do. That said, sometimes you are forced to rely on the user to make decisions. Okay, so the user will have to make security decisions. And in that case, what the software should do is it should sort of guide the user and give them feedback. Okay, so guiding the user means that the interface, say it's software. By the way, usability doesn't have to be software, but I will talk about software because it's the easiest. But you can talk about the usability of hardware or physical device or whatever. But anyways, I'll probably say software a lot, but just keep in mind that it doesn't strictly have to be software. But what the software should do is it should help the user do what they're trying to do. Okay? It should explain things. It should, like if you hover your mouse over an icon because you don't know what it means, it tells you what it means. that kind of thing. Or maybe there's like a wizard kind of interface where it says, okay, you're doing this, what do you want to do? You're doing this, and you sort of click next, 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 and it kind of walks you through. The developers and your users are not the same people. So a lot of time your developers will say, well, it's usable, I understand it. We did it, we went through it, and we really understand it. But the developers know how it works, right? They have the proper mental model of the software. And so it's going to be easy for them, right? They're not going to understand why other users are confused, or they won't even see it. They won't see why it is, okay? So when you do usability evaluation, ideally you want to do it with users themselves. You don't want to do it with your developers. But we'll see there's different ways of doing evaluations. Another thing is that defaults are important, okay? So whatever, usually like software will come with a set of defaults, and most users will not change those defaults. Okay, they'll just go with whatever it is. If it becomes a problem at some point, then they might go digging into the settings and things like that, okay? Usually when you install software, you probably don't go through all the settings and look at everything, right? You just start using it, and if something's not working, then maybe you go into the setting to try and fix it. But in general, if it's working and you're getting your tasks done that you want to, you're not going to touch them, okay? And the final thing is that when you use software, you have, well, we call it a mental model. So it's basically like how you think it works, okay? What it's doing for you, how you think it works, okay? So for example, Tor, we'll look at that next class, okay? Do you know how Tor works? Maybe you do, maybe you don't. You will by the end of next lecture, okay? Do you have to know how it works in order to use it? Right? So to some extent you do, right? But you don't have to have perfect knowledge of how it works. You can just use it without actually knowing everything, okay? So when you're designing software too, you want to educate the user, you want them to understand how it works. Maybe the software is going to try to educate them a bit. But the users, they just want to use it and they don't have to have perfect knowledge of how it works, okay? So you can accept the fact that their mental model is good enough, but it's not perfect, okay? And in some cases, users can actually have the wrong mental model, and it's okay. As long as the wrong mental model leads them to use the system correctly, then it's okay. I'll give you an example of that in a second. Any questions about any of these things? Okay. Okay, so I'll tell you some stories about a few of them. Whoops. Okay. So the first thing is these examples, a lot of them, they aren't about software and security. They're just from general life. What this is a chart. And you can see a bunch of countries. Okay, they're all countries in Europe. And you can see some rate. So you can see that for these countries, whatever it's measuring is really, really high. And for these countries, it's really, really low. Okay. This is a chart of people who, it's kind of morbid, but anyways, apologize. But let's say that you get in like a car accident and you die. Would you donate your organs to someone else that needed them? Okay. And so in these countries, you can see that like 99, almost 100% of people in Austria would donate their organs. But if you go over to Germany, it's only 12%. Okay. So why is that? What's the difference? Is Germany and Austria that much different? Are their cultures completely different? So that could be one theory. So your theory could be, well, I think there must be some difference between the UK and France, right? Okay. So that was the going theory. But if you look at it, a lot of these cultures are the same. Like there's lots of Germans in Austria. And so if you look at the Netherlands or Belgium's a good example because it's kind of a mix of, people who are Dutch, people who are German, people who are French. But yeah, it's all over the map in terms of like there's no consistency to it at all. Okay. So the answer to why this is the way it is it has to do with defaults. In the countries that are blue, if you sign up for a driver's license, they're going to ask you basically whether you want to donate organs. That's when you make that decision, okay? In the blue countries, by default, you do it, okay? So if you just fill out the form, by default, you're an organ donor. And if you want to opt out, you have that right, but you have to ask for a separate piece of paper, and then you have to fill it out. And if you do that, then you can opt out, okay? In the yellow countries, by default, you're not an organ donor. Again, you can decide that you want to be. So in all countries, you can decide one way or another, but in the yellow countries, the default is that you don't. So if you just fill out the form and leave, you're not an organ donor. And if you want to be an organ donor, you have to ask for a second piece of paper, and then you have to fill it out, okay? So why is the rate so high in blue countries? Because everyone just does the default. You do the minimal amount of paperwork, okay? So anyway, defaults in software are a lot like this, right? And part of this is from a book called Nudge, and their point was actually if you think about what the defaults are, and if there's something you actually want, like it's probably as a social good, it's probably better to have lots of organ donors, right? So we probably want to be living in a blue country as opposed to a yellow country, okay? And in this case, you're not taking anyone's freedom away. Everyone's able to do the same. All you do is you go in and flip the default. Okay? So similarly in software, if you want users to behave securely, right? Sometimes you can go in and flip a couple defaults, and then now users will just behave more securely. You're not taking anyone's freedom away. They're able to go into settings and change it, but just as a, most users are just going to roll with the default anyway. Okay, mental models. So here's an example of a car steering wheel. Okay, how does a steering wheel work? What does it do? These are dumb questions, but what does a steering wheel do? Steers, what does that mean?
Direct the wheels.
Okay, so if I turn the steering wheel like this, what happens to the wheels? Okay, they go like this, and if I turn it like this, then the wheels go like this. Okay, so if I want to go to the right, I turn to the right. If I go to the left, I turn to the left. Now, is the steering wheel is that like a mechanical thing? Like literally turning the steering wheel is like somehow goes through a bunch of gears and things like that, and it turns the wheels? Yes or no? Who thinks yes?
Yes.
Who thinks no? Okay, you're both right. So it depends on your car, it depends on the year. But if you go buy a brand new car today, probably not, okay? Your mental model though, so your mental model is that it's connected. Like your steering wheel, there might be like power assist or something. So if you get an old enough car, like literally the force that you put on the wheel is the force turning the wheels. Like it's hard to steer those cars because you have to really turn them. Then there was like power assist so that like a motor would kick in and help you move it. Then there was like the computerized cars that we have today where this is just a joystick. And so you turn it, it tells a computer that you want to turn the wheels, and then the computer sends the signal to the motor, and then the motor's on the wheels and turns them. Okay? All right. Doesn't matter. But anyway, your mental model is that this steering wheel is turning the wheels, or at least your mental model is if I turn to the right, the wheels are going to turn to the right. Okay? Here's another question. Is there ever a case where I turn the wheel like this, and instead of the wheels going like this, they go the opposite way?
Reverse.
Okay, it could be in reverse, but it isn't. So when you reverse, you do have to change your orientation. It's a good guess. So I'm driving in a straight line, and I go like this, right? And the wheels go like this instead of going like this. Would that ever happen in any circumstance? Okay, so there is one circumstance. Yeah. Yeah, exactly. So let's say you lose control of the car. There's a traction control system. And if you start skidding, say you start skidding in this direction, you're turning the wheel because you want to get out of the skid and go the other way. But what you have to do is you have to bring the wheels in line with the skid so they regain traction. And then once they regain traction, then you pull the car back. So if it's a fully manual car, like no automated systems or you have traction control, if you want to go that way, you actually have to turn this way a bit first before you turn back. If you drive on snow, you might get used to it. But now a car will do that automatically. Okay? So it interprets me going like this as I want to go in that direction. And if it decides for traction reasons it's best to put the wheels in this direction, gain traction, and go there, it just makes that decision for me. I don't have to think about it. Okay? Now, my mental model of how a car works is wrong. I think that when I turn the wheel, when I turn the steering wheel, yeah, the tires turn, right? It's wrong. Okay? Really, it's a computer, and sometimes when I turn, like in rare circumstances, it might go the wrong way. Do I need the right mental model to drive a car? I don't, right? I have a mental model, it's wrong, but it's fine because the car, it just knows what I want to do. When I go like this, I want to go that way, okay? I don't have to know about traction control and power assist steering and all that type of stuff, okay? So sometimes, it's okay if users don't understand what they're doing, as long as they get the job done, right? As long as they do it in a secure way, it's fine, okay? And so sometimes, you could go around telling people like the steering wheel turns the wheels, and it's actually good advice because it gives them the right mental model to use the car even if the mental model is not correct. All right. Okay, so now you have a piece of software, hardware, whatever, and you want to try and figure out whether it's usable or not. How do you actually go about doing it? What's the methodology? So we'll talk about 3 methodologies. The first is what we call an expert review. This is the one that you will do yourself. You're going to do this in assignment 2. It involves one expert. The second is a user study. So basically you bring a bunch of people in, you make them use the software, and then you measure a bunch of stuff, okay? So you might have 20 users, you might have 200 users, usually across a 1-hour period. And then the final type of thing you can do is what's called a field study. And in this case, you actually roll the change out to the real users. Sometimes you might roll it out to half of them. So you might pick a random 50% of your users, half of them see the new tool, and half of them are using the old tool, and then you're going to measure some differences between the two groups. And usually you would run this sort of experiment over the course of days or months as they're using it. Okay? Now, if you look at this, it's probably pretty apparent, but the best user study would be the last one. Okay, it would give you the best results, and the first one's going to give you the worst results, but the first one will give you good enough results that it's okay to do. Okay, and you might start with the first and then go to the second and then go to the third. Okay, and it's also way more expensive to do the third than the second, and it's more expensive to do the second than the first. Okay, so these are going to get progressively better as we go through them, but we'll take account of those things. Okay, so we'll just go through them one by one. So expert review. Okay, so what you do in an expert review is you pick someone that's going to review the software. Again, I keep saying software, but it could be anything. You could use one person. Sometimes you might use a small number. You might use 2 or 3. And then at the end, you might do an agreement between them to figure out what is it that they agree on or disagree on. In assignment 2, you'll just do it yourself as an individual. Okay, the person doing the review needs to be what we call a dual expert, okay? So we want someone that is an expert in usability. So they have to know what the methodology is, what they're looking for as they do it, okay? So that's the first expertise. The other thing is we want them to actually have a proper mental model of how the system works, okay? So they do have to understand how it works because it's going to be easier to identify when users might do things wrong, or there might be inconsistencies between what the user thinks and how it actually works. So you have an expertise in usability evaluation. So before assignment 2, I'll try and give you that. This lecture, we'll just talk about this at a high level, but next week we'll go through the actual details of doing one kind of expert review that's called a cognitive walkthrough. And then you'll need some expertise in the tool that you study. Next class we'll do Tor. So before we do the usability study of Tor, I will spend a bunch of time explaining to you how it works. Okay. For the assignment, part of the assignment you'll have to do a bit of research on what you're studying. Okay. So the thing you'll be studying is like a privacy tool for managing cookies on the web and seeing what cookies are tracing you when you go to various websites and things like that. So you'll have to learn a little bit about cookies probably in order to do an effective job at the evaluation. Okay, so cognitive walkthrough is one kind of expert review, probably the best kind, and it's the kind that you'll do. what it does is it starts with a bunch of tasks that users would actually want to do. Okay, so you look at a system like Tor, you're like, okay, the user, they need to install it, they need to connect to Tor, they want to go and browse to a website over Tor, they want to know that they're anonymous when they're on the website, right? So these are kind of like the tasks. And the way you do it is you basically do those tasks as if you are the user. You kind of role play as if you're the user, and then you look for certain things where the software isn't being usable, and you'll have a set of guidelines that you can follow that I'll show you. Okay, now this maybe sounds obvious, like how else would you do it, right? But the main alternative is something called heuristic evaluation. And in heuristic evaluation, it's more like you would open the software up and you would look at every single button. You'd be like, I'm in Keynote, like, what does this button do? What does this button do? What does this button do? What's this stuff? When I click on this stuff, what does that do? Oh, what does this menu item do? What is this menu item? And so you go through the software interface basically button by button, element by element, and that's how you study the usability of it. Okay? So cognitive walkthroughs tend to be a little more realistic because users, when you get software and it's brand new, you probably aren't going to go learn what every button does, okay? You're just going to try and use it, and you're hoping that it's intuitive enough and you can understand how to do it, that you can just jump in and use it. So that's what a cognitive walkthrough models. Both of them are okay. You can do either of them or do both, but anyways, we'll focus on the cognitive walkthrough. You can also, another car example, sorry for all the car examples, if you get a manual for a car, like you get a car and it comes with a manual that explains how the car works, right? Some of it, especially like older cars, older manuals, when you read the manual, it is sort of a button by button explanation. It'll be like, here's a picture of your dash, and here's every button on your dash. And if you press this button, it does this. If you press this button, if you see this light, this is what this light means, okay? So there is that kind of way of doing a car manual. That's like a heuristic evaluation. And then there's the car manuals, the modern ones, where it's like, I got a flat tire, what do I do? And it's like, okay, step 1, do this, step 2, do this, step 3, okay? So that's more of a task-oriented manual. And most of them are kind of a blend of both. So you'll see some aspects that are sort of explaining things button by button and some things that are more of a step-to-step guide. Okay, when you're back to the cognitive walkthrough, so you're an expert, you're going to do the walkthrough, you're going to pick the kind of user you want to emulate, meaning you have to make assumptions about the user. Like, this is a user that has never, like, okay, Tor, right? Is this like a hacker that's using Tor, right? That's one kind of user, and you can do the walkthrough modeling that. Or you could say this is a journalist, who's using it that doesn't know anything about computers, right? And so both of them are the kind of users that the Tor people would want using Tor. So it's suitable to do both of them, but your results are going to be very different because the hacker is going to have a lot of technical knowledge and they're going to be comfortable with like a lot of tech, and the journalist won't be. Okay, so it might be usable for one and not usable for the other. Okay, so you have to pick the kind of user that you want to emulate the study for. Then what you do is you pick tasks that you want to study. Okay, so we look at the core tasks. So the core tasks are like the main tasks. And you can do as many as you want, basically as much time as you want you can spend. But like when we look at Tor, we'll look at 3 or 4 core tasks. I think for your assignment, I asked you to do 6 or 7. I think I asked you to brainstorm 7 core tasks, but then I'll actually just do 3 for the walkthrough itself. But anyways, you figure out what is it that the user might want to do, and then when you have a list of them, then you'll have a list of them. Then the final piece before you get started is, what does a usable system look like? What does it look like for a system to be usable? And so what you'll have is you'll have a set of rules or kind of like indications that a system is usable. Okay, so we call these guidelines. And some examples of them would be like, the interface guides the user. The language that's used is easy to understand. The user can figure out the next step. Things like that, okay? So you have a bunch of these guidelines, and you'll see an exact. I'll give you the guidelines for the assignment itself, so you can use those guidelines, okay? And then what you'll do is you'll just simply walk through the system. So you'll complete the core task, and at every step you'll ask yourself, is there a problem with any of the guidelines at this particular step? Yes or no. If there is, report it. If there isn't, then that's fine. You can move on, and then eventually you reach the end of the task, and then you're done. Okay. So you'll see a concrete example. We'll do an example together next class. So we'll come back to this. Okay. Now, relative to the other kinds of usability evaluation you might do, is a cognitive walkthrough good or bad? So the good part of it, the pros of it, are you can do it really fast. It's just one person going through the software. It's cheap. You're not paying users to come in. You're not deploying it in a field setting. And because it's fast and cheap, you can cover a lot of the software. Okay, so you can spend a lot of time looking at all sorts of different aspects, you could do 100 core tasks or something like that, and it would be reasonable. Okay. The cons are that the expert's going to make mistakes. Okay, the expert is not a user. They're role-playing being a real user, but they aren't actually a real user. And so they're going to make mistakes. And in any mistake system, any system where you make mistakes, there's always two types of mistakes. Okay, false positives and false negatives, or type 1, type 2 errors. Okay, so what does false positive and false negative mean here? So the obvious one is the expert misses something. So there is a big usability issue. A normal user would struggle with it, but because the expert knows the system, they're not going to struggle with it. They're not going to flag it. So that's the false positive. But the opposite is also true. The expert might say, I really think users are going to struggle with this. But then when you put real users through it, they figure it out. Okay? So you might waste a lot of time trying to really simplify things when it doesn't actually need simplification. Your real users are okay. So the first one is probably the more pertinent one, but the second one is something to keep in mind too. You don't want to spend a lot of time. I'm always in favor of making it as usable as possible, but it is possible to go too far in terms of spending too much time on things. Okay, so the next kind of thing that you might do is a user study. So a user study, what you're going to do is you're going to bring actual users in, and you're going to have them use the system, usually in a kind of laboratory setting. So like at university, we'll do it a lot. So we'll have a room in the university, we'll bring someone in. Your study would be somewhere, probably you wouldn't want to do it with less than 20 people. And if you do much more than 200, you're probably not going to find things that you didn't find in the first 200. Okay, so the more the better, but you also have costs and time and things like that to consider. So that's why you might not go all the way to 200. We'll come back to what the difference is between doing a study with 20 and 200 a little bit later. Okay, so how do you do a user study? So the first step before you do anything at a university setting, if you're in corporate setting, it might be different, but in a university setting, you first have to get clearance from the university to do the study. So anytime you do something with human participants, okay? So if you want to do a user study for your final project, you can't do it unless if you already got ethics. And if you're like, I'm going to apply today, it takes a couple months to get the ethics clearance. So there's not enough time to do it. But anyways, it applies to any study with human participants. Now, let's say I'm just studying security software. I'm going to bring you in and make you use some software and try and figure out whether you're doing it secure or not. It's not like I have an experimental drug that I'm giving people and it might have wild side effects, right? Are there actually ethical concerns that I need to worry about? And so the answer is that they're probably more moderate than if you're doing drug trials and things like that. But there are some actual real things that you would have to consider. So the first thing is that there's a typo here. What you do is you basically describe the activities. So you'll just fill out a report. You're saying, I'm doing this study. This is what I'm going to do in the study. In a study, you always have to collect data from people, who your participants are, what their demographics are, and things like that. And you have to do something with that data. You have to figure out who has access to the data. How long do you keep it for? Are you going to delete it? Are you going to make it public? So a lot of the ethics has to do with the data collection. Okay? So in general, you have to hold on to it long enough that, say someone questions the scientific validity of your study, you can show them the data, right? But at the same time, you don't want to keep people's, personal data on a Dropbox, right, for 10 years or something like that, right? So you might have to anonymize it or at some point delete it. So anyways, that's one aspect that you have to take care of. Okay, the second has to do with deception. So deception is used in almost all studies. So if you bring a user in and you're like, I want you to browse the web and we're like trying to figure out whether you follow best security practices. If you tell the user that, then what are they going to do? They're going to follow the best security practices, right? Like someone's in the room with them with a clipboard, writing down everything they do, looking over their shoulder, right? If I ask you to generate a password in that setting, you're going to pick a big, long, random password, right? Because it's about security and you're going to be on your best behavior, okay? So, but you want, as a person doing the user study, you want people's real responses, their genuine responses, okay? So normally you don't tell them it's about security. You're like, hey, we have a new online game and we just want to see whether it's fun or not, okay? So sit down. Oh yeah, you have to create an account and a password, so just do that and then we'll get to the game, right? And then they do that and then they play the game. And then at the end, you're like, actually, I didn't care about the game, right? It has nothing to do with the game. It was that step where you had to create the password. That's what the study was about. Okay, so that's deception. You always use deception, almost always, with security. Otherwise, you'll prime your users to act more securely. And then what ethics will do is they'll say things like it depends on exactly what you're doing, but deception is acceptable. So you can deceive users, but usually you have to disclose it at the end. So at the end, you have to tell the user, actually, this study wasn't about what you think it is. And then usually you give them a chance to opt out as well. So they could say, well, you know what, you tricked me. I thought this was about playing a game. I'm not comfortable being a part of the study anymore. And then you give them a chance to leave the study. All right, so you'll write up your activities. Are you using deception? Are you collecting data? How long are you retaining the data, that type of thing. You'll submit it to the university. There's a bunch of, I think they're professors, I'm not sure. They sit on a board, they review all the files, and then they come back to you and say, change this, change that, or we approve it. All right, so that's step one. Step two is you need some users for your study. So you're going to advertise it. Now, where are you going to find your users? So you could put, posters up around the university. That's fine. What kind of users are you going to get if you have posters up in the hallways of a university? You're going to get a bunch of students, right? So that's maybe fine, maybe not. Are students representative of your actual users, right? So they may or may not be, right? Students tend to be from an age range, right? That tends to be younger. Maybe your users are older, right? Students are here at a university, right? Their education level is probably higher than a random person off the street. Is that okay for you? Are your users of a higher education or are they of a lower educational level? Okay, so you have to recruit the kinds of people into your study that are going to match your users to the best of your ability. Okay, so how you advertise it, where you advertise it, that's difficult. One thing that university groups that do a lot of user studies that do is they have people from the community that they found from past studies, and they sort of have a list. And so they have a bunch of people that do these studies, and they're willing to do the studies, and the university sort of knows what their demographics are, and then you can choose from the list. Another thing you could do is you could do it online, depending on what you're studying. So if it's something that's completely digital, doesn't have to be done in person, there's no in-person component, like using software is a great example, then you can also recruit users online. You don't have to actually meet them or talk to them. So there's platforms that allow you to pay users to do simple tasks, short tasks usually, and so they're good for user studies. In fact, they're so popular that people have written papers of like so one of them is called Mechanical Turk, and it's owned by Amazon, and like who are the users when you go on this site? And so they spend a lot of time figuring out who these users are, what their demographics are. And so you don't have to do that as yourself doing the study. You just do a Mechanical Turk study, and then you read this paper to figure out what the demographics are, and then you can report what your findings are. Okay, so now you have a bunch of users. Before you drop them directly into the user study, normally what you do is you do like a screening. So screening is usually a questionnaire. You have it fill out. And the main thing you want to do is you want to understand their demographics. So age, education, income level, expertise at like computers. These are all things that you may consider. There may be more or less depending on what your study is. Okay. Once you have your demographic, then what you have to do is you have to play the game of, here's what I think my real users are like. Here's what the people who signed up for my study. I had 200 people who said they're willing to do this study. I only need 50 of them. Which 50 am I going to choose? Well, I'm going to choose the 50 that look the most like my actual target user. Okay? So you'll do some statistics or some math in order to try and match them up. Now, sometimes you can't get the right users, right? Like say your user group are they have high expertise in something, and you do a lot of recruiting, but the people that are coming in the door, they aren't highly expert. Or you can get 5 experts, but you need 20 or you need 50, right? So then what you might do is you might do you might monkey with the math a bit and say, okay, this person is like more representative of my users. So like whatever they do counts for like twice as much as what someone else does. So you can try and close that gap using statistical weighting. And so that's fine. It's not ideal. It'd be better to have users that actually match the demographic. But this is like a trick that could be used as a last resort if you can't. If you can't match your users to your if you can't match the users in your study to the actual users of the system. Are there any questions so far, by the way? Just interrupt me. Okay, next thing you do is you pay the participant, and you always pay them before they do the study. Why? That seems weird. Why wouldn't you pay them at the end? What if they walk out in the middle? Yeah.
It's better because if you pay them at the end, they might like black out or just not take it seriously after a point. And it's better to pay them up front and have them leave midway than this.
100%. Yeah, exactly right. So if you hold payment to the end and say you only get paid if you complete the study, if a user gets bored in the middle, they want to get paid, right? And so they're just going to be lazy for the last half. They're not going to try. They're not going to put an effort in because they want to get paid. But that's going to hurt your results. It's going to hurt your data, okay? So what you rather do is the moment that they want to give up, you just say, fine, just leave. It's fine. Then you don't have to include their data because they left the study, and they're not going to ride it out to the end just to get paid because you paid them at the start. Okay? So in order to preserve your data and keep your data like intact, you pay the user and they are free to leave at any time. Generally, users aren't going to do that. They could try and take advantage of it, but generally they don't. So usually you give them a fixed payment. The study usually has a time limit. 30 minutes, 60 minutes are standard times. Sometimes the researchers don't have a lot of money. So normally you would give someone, I don't know, $20 for half an hour or something. I don't know what the rate is, but let's say it's that. But maybe I have 50 users and I can't pay them, like that adds up and I don't have enough money. Then what sometimes people do is they'll be like, okay, we bought an iPad, and if you do the study, we'll put your name in a lottery, and one person who did the study will win the iPad. Okay, so you'll see this a lot. I see it a lot in emails, especially like for surveys and things like that. Fill out our survey, and you can have a chance to win one of 3 iPads or something like that. And the idea is that the total cost of the iPad is less than what you would pay on a per user basis. Yeah, and then as I said, payment shouldn't be contingent on completing the study, or it could bias the results. One exception to it is that sometimes, like in business, the amount that you get, they'll make you play a game, and it's for real money. So like if you play the game well, you get money, and if you don't play it well, you always get like a fee for participating, but you could make more money depending on how well you play, and that's to give you an incentive to play as hard as you can and be competitive. So those are the kinds where like the payment might be contingent on aspects of the study, but in security, for the kinds of stuff that we would do, you would get paid at the start.
So what about making the payment before and after?
So again, the problem is that a user who gives up halfway through, if there is, even if it's half of the payment after, they're still going to ride out the last half till after. So you want to you want that user to leave, and if the payment is what's keeping them in the study, then you've got to pay them before so that they leave, basically. Yeah.
Does this apply to any other topics, but only in security?
No, like every single user study. With the exception of those like kind of business games, like where you're playing stock markets and there's real money because you want to incentivize the user. But yeah, in general, any study you would get paid at the front. Any study where giving up in the middle, like I guess for like medical things, like it's too late. Like there is no giving up in the middle. I guess, well, maybe there is. But anyways, you can think through it. But anything where the data could be damaged by someone kind of soft quitting in the middle, like not actually leaving, but just not trying. Any kind of scenario like that, then that would be the scenario where you'd have to pay them up front. So definitely way more general than security. It's not a security specific thing. Okay, finally, at step 5, we're ready to do the actual study itself. So studies are very carefully designed. Every detail of the study, exactly what you're going to ask them to do, is designed. Sometimes you do it in iteration, so you bring a couple users through, you refine it, then you bring a couple more through, and then finally you're happy with it. What you want to do is you also want to make sure that every participant is sort of treated equal in the study. So you don't want to like give a lot of information to one person and not a lot of information to another, because if you do that, then the one person's going to perform better, and it has nothing to do with the software. It has to do with you as in terms of what you instructed. So what you would typically do is you would actually like write down everything you would say to the user and just read it off a script. Now, sometimes users will ask you questions, and different users will ask you different questions. So you can't say the exact same thing, but instructions to the user and things like that would either be written and you would ask them to read it, or you would read it off the script. So you try and keep everything the same. All the variables of the study that you can control, you try and keep the same. Often you do like a smaller pilot study first, and then there's different ways of designing a study when you compare two different systems. So it's very typical in security. You could do a study where you're like, okay, I have this system, is it secure or not? That's my goal for the study. It's really, really hard to like determine like what is secure. It's not really a well-defined concept, okay? A much easier study to do would be, here's the way people are currently doing it, and here's my new system, and we're just going to do a comparison. Which is it that users like better? Which do they perform better with, okay? Or here's the competitor system, and here's my system. Let's do a side-by-side comparison, okay? So comparing two systems is usually, like, most studies are about comparing two things as opposed to just, trying to say something about one study or one system itself, okay? So comparative studies are the most, are the best. Now, let's say that you have two systems. So you have system A and system B, and you're trying to decide which one's better, okay? So I bring in the user, I say, okay, do system A. We walk through it. Then I say, okay, now I have a different system. Now I want you to use that. And then they walk through system B. And then at the end, I try and figure out which one's better. Is there any problem with that type of study where I would get them to do system A and then I get them to do system B?
They will get experience by using the first system, so it won't be like starting from 0 when they test system B, so that it might skew the results towards a different way.
Perfect. Yeah. Okay. So if you get someone like I don't know, you have a VPN or something like that. You get them to use System A. Maybe they never used a VPN before, but after they're done using the VPN System A, they know at least a little bit about VPNs now. Okay. They learn something. So then when you get them to use System B, they might be a little faster, a little more comfortable. Just not because System B is better than System A, it's just because they themselves are a little more comfortable because they use System A first, okay? So in those types of studies where you do one after the other, it tends to bias toward the second one being better because users learn something from using the first, okay? So we call that the learnability effect. How do you fix that? Okay. So there's actually two solutions to it. The one solution that's not so great is you could randomize which one they use first. So someone comes in, some people will do A then B, others will do B then A, and then you hope it cancels out. Okay? The better approach, which is called between subjects, is some users will use A and they will never see B. Other users will use B and they'll never see A. Okay? So you keep them completely separated. Okay. Now the problem with that approach is if you want 20 users to use A and 20 users to use B, you need 40 users. Okay. If you're doing A and then B, then you only need 20 users. Okay. So, and let's say you have 3 comparisons or 4, right? Now you have 4 different groups and you need enough people in every group. Okay. So doing between subjects, the only downside to it is you need enough users in every subject in order to do it. But in terms of contamination from using one system spilling into using the other systems, there's no problem with that because users just use one and they don't see the others. All right, so there's a learnability bias if you use System A followed by B. And so the best thing is to split them into 2 groups. Oh yeah, and then how do you choose who uses A and who chooses B? Well, if you put all your experts in the group that uses A and all your non-experts in the group that uses B, then A is going to look better than B, right? But not because of any differences between A and B, just because of where the experts are, okay? So there's 2 ways of doing it. One way is you could go through the demographics and you could try to, balance everyone between the 2 groups, okay? The other approach you could do is just random. You just randomly assign it, and you hope that statistics takes care of it, okay? Random assignment is good if your groups are big. So the bigger your groups are, the more likely that that's going to cancel. Any differences between it will cancel out. But if you have small groups, like say you only have 3 people and 3 people, then there's a lot of random draws that would actually have your 3 experts in one group and not in the other, okay? So that's, depending on the size of your groups, you would have to choose between them. Or you could do a random assignment and then look at the demographics and then decide whether it was good or not. Okay, so now we're done our user study. And so we're going to look at what are the results of the study. So to have any results to look at, obviously you would have had to collect something during the study itself. You're going to collect some data. And the data that you collect are usually of 2 things. So you have quantitative data, which are numbers. So how long did it take the user to do this? It took 12 seconds. That's a number, okay? And if in System A, it's taking people on average 12 seconds, and in System B, it's taking people on average 20 seconds, then you can say something about the difference between those 2 systems, okay? So that's quantitative. Now, a lot of security things aren't quantitative. Like someone doing something faster doesn't mean it was necessarily more secure or less secure, or they trust the system more, or they trust the system less. A lot of security is it's not about numbers, right? And so people's thoughts and feelings about things we call qualitative. Okay, basically they're just not numbers, all right? So you can collect qualitative information from users. You can ask them questions, they can answer questions, you can ask how they feel, that type of thing. So quantitative would be the users completed the task 7 seconds faster on System B. User errors decrease from 18% to 4% with system B, so these are quantitative. Qualitative would be like users like system A better than system B. Okay? Now, let's say that you want to run statistics at the end and figure out whether A is better than B. What do you do with qualitative system? Like, what do you do with that data? You can't put numbers on it, right? So you can't really report. I guess you could count like how many people say they like A better than B as opposed to B better than A. But let's say you just ask them like some open-ended questions, like how do you feel when you use system A? And someone's like, oh, it makes me feel good. I feel like it's secure. And another person says, you know, I really worry about this one aspect. You know, so you have these like full paragraphs coming back to you from your users. How do you turn that into a result? Okay, so the answer is you want to convert it to a number. So let's say that you want to get people's thoughts and feelings about things, but that's not good enough. I want a number. How do I do that? How do I convert qualitative data into a number? And the answer to that is something you all know. Everyone in this room knows how to do it. You just might not know, you might not make the connection between what you know and to the answer of this question. Does anyone know what it is?
You do a rating of emotion?
So not quite, but that's a good guess. Yeah. So rating is the right word.
The Likert scale?
Yeah. So you've watched the videos ahead of time, I guess. But it's yeah. Exactly. So have you ever seen this? You know, here's a statement. I strongly agree. I disagree. I strongly disagree. Right? You probably filled out lots of these before. So this is called a Likert scale. All right. And why do you do a Likert scale? Well, now it's a number. This website is easy to navigate, right? Now I can make that a number, right? I give 1 point if it's strongly agree, or I give 2, I give 1, I give 0, I give -1, I give -2. And then I can average out across a bunch of users and I can say, okay, there's a numerical difference between how people answer this question or not. Okay, so this is a Likert scale. It's used to convert qualitative data into quantitative data. Now, there's some problems with it though, okay? Let's say that you ask people 100 Likert scale questions and they get bored halfway through. What are they going to do? Okay, so they might stop caring, they might randomize their answer, they might just be like, I agree, or like I strongly agree, strongly disagree, that kind of stuff, okay? So user fatigue is a big issue. So what can we do about user fatigue? Okay, so one thing is we can simplify it. Less questions, right? Simpler questions. So that's idea one, that's valid. Anything else?
Make it more interactive.
Sorry?
Make it more fun.
Yeah, maybe more fun, or the questions are more engaging.
Lunch breaks.
Change the way, like agree, disagree, then write the paragraph, then.
Okay, so we could vary the questions, add some variance or something like that. Yeah, so that would be a way to make it more engaging, basically.
Option to skip if they don't want to answer.
Okay, so we could let them skip all the way through, or we can give them a dummy response of like, yeah, I'm not going to answer that, just so that it doesn't corrupt the data.
Limitation answers.
Yeah, like the length of the,
Just 3 options.
yeah, so you could simplify, again, other kinds of simplifications.
Discard the useless survey.
Like discard.
Discard the useless.
Yeah, but how do you identify that? So here's another reason. How do you know when a user starts doing that?
All the same position of the.
But what if they actually strongly agree with everything? No, but could you trick them? Could you actually say?
Change my presentation. Change the way of my presentation.
Okay, so that could be one way. One thing you could do is you could ask them the same question more than once. Okay, if you ask them the exact same question 3 times, you can see, do they answer the same way all 3 times? Okay, then what you can do that's really fancy is you can flip it around. So instead of saying this website is easy to navigate, I strongly agree, later I'm going to ask them, this website is hard to navigate. Okay? Now, if they're doing strongly agree, strongly agree, strongly agree, there's a contradiction because they strongly agree that it's easy to navigate and they strongly agree that it's hard. Okay? That's how you tell and you say, okay, I see that, I'm throwing away this data. Okay? So it forces you to like try and see. So you see agreement between them. Now, the problem with that is it makes the survey a little longer, which is contributing to the fatigue. But if you take these surveys, you will notice that sometimes you're like, I think I already answered that question. But they are deliberately asking you the same question more than once because they want to see whether you are actually paying attention to it. Okay, so you can shorten the survey. Another thing too is that people will probably think about question 1 a lot, and they'll think about question 99 not a lot. Okay, so you'll get good data on question 1, you won't get good data on 99 because everyone's tired. So one thing you can do is randomize the order so that every question will be somebody's first question or in the first page of questions. The consistency checks are what I mentioned, and yeah, that's basically it. Okay. Then when you have your results and your data, you're going to do some statistics. Basically, you'll write down what you think your hypothesis is. A hypothesis is just a fancy way of what's the statement that you're trying to prove or disprove. So it might be like system A is better than system B, something like that. Okay? And then I'm not going in this class through the statistics. So I even am not comfortable with them. You need to take an entire course on statistics to get comfortable with the kinds of things that you want to do. But basically, you'll write down your hypothesis, you'll crunch a bunch of numbers, and the numbers are going to say you're in one of 3 buckets. Okay? Bucket 1 is the hypothesis looks true. Okay, the data is telling you that the hypothesis is true, but there's always a chance that it's just random, right? It's just like those users happen to do things better than those users. Okay, so there's always that chance. But the more users you have, right, the less the probability is that it's just due to random chance. And the greater the difference between the two groups, as it gets greater and greater and greater, it's also less and less likely that it's due to random chance. And it's more likely that it's the hypothesis. Okay, so the bigger differences, bigger number of people mean that you're going to be able to tell the difference between your hypothesis being true and it just being due to random chance. But anyways, so it could look true and it's more likely than random chance. It could look false and more likely than random chance. So in that case, the opposite is true. So my hypothesis is system A is better than B. I did the study and the study actually proved that B was better than A. Okay, so that's fine. So both of these are good results in the sense that you have a conclusive answer. And then the middle ground is when it's inconclusive, okay? So the hypothesis, it might kind of look true, but it's within the range of just being able down to like random chance, okay? We can't really tell that it's not just random chance, right? So it looks slightly true, slightly false, but we can't rule out that it's random chance. You'll sometimes see like the term like with polls and stuff like that, like it's in the margin of error, okay? So this means it's within the margin of error, meaning maybe it's true, maybe it's not. And there's this concept of statistical significance, which basically tells you when you calculate the significance and it will tell you whether you're in case 1, 2, or 3. So if you're in one of these 2 cases, we say the result is statistically significant, meaning that it's not, most likely not due to random chance. And here it's not statistically significant. Okay, so basically the number of participants and how strong the difference is are the 2 factors that determine whether you'll get statistical significance or not, okay? So if you have less than 20 participants, you're going to have a really hard time getting statistical significance. If you have around 20 and the effect that you're measuring is strong, people really like A better than B, then you'll be able to determine that. You'll prove your hypothesis is true, you'll prove it beyond the margin of error, and you'll have a significant result, okay? But if it's a very subtle thing, people slightly like A better than B, then it's going to be within the margin of error. And the one thing you can do is if it's not coming back significant, you can just run more participants. The more you run, the greater whatever is looking true or false, the greater it's likely to be actually because of the hypothesis and not because of random chance, okay? And so if you go up to about 200 users, that's when you can start getting significance for like more subtle kinds of effects, okay? So again, this is like very just broad numbers, but it's just to give you a sense of kind of like what these studies look like in terms of size. Requires a lot of expertise, so it's not something that you like go and ask ChatGPT how to do, or you read the Wikipedia article on like T-student test or something, and then you try and do it. You have to really know what you're doing. Okay, so user studies, the pro is that you're testing with normal people. The con is that even though they're normal people, they're not developers, they might not actually match your demographic. There's only so much you can cover in 30 or 60 minutes. Okay, so you can't get them to really use the software for a long time. You have to think about whether they're behaving, when they're in the lab, are they behaving the same way that they would behave, say, at home? So that's called ecological validity. So you're in a lab and people are watching you and they're writing down every single thing you do. Are you on your best behavior, or are you behaving the same way that you would at home? Okay. It's expensive because you got to pay all the users, and it's also expensive in terms of time because someone has to administer the study, so they have to be there the whole time, and you bring the user in, and it takes days and days and weeks to put all the users through. And then there's long-term issues that might not show up because, like, again, I'll give the example. If you see a security warning the first time, you'll spend a lot of time thinking about it. If you see it for the 99th time, you won't think about it at all. But in a user study, all your users are new. They never used the system before. They maybe do something that triggers a warning, and so you're seeing their first reaction to the warning. But by the time they leave 30 minutes later, they've probably only seen it once or maybe twice. They haven't seen it 99 times, and so you actually have no idea how they're going to react the 99th time. Okay? You're just seeing their first reaction to something, not their long-term reaction. So you could miss issues as a result of that. Okay. All right, so that's a user study. So why don't we take a 10-minute break, and then we'll come back and I'll give you an example of this, and then we'll talk about field studies. Hi. Yeah, do you have specific questions or like?
So you mentioned columns and things. So actually I started to look into deployment today.
Yeah.
And in the last question, you specifically mentioned the deployment and the
All right, we'll get started again. Okay, so I wanted to show you one example of this point at the end of fatigue issues and habituation. It's sort of a fun example, it has nothing to do with security. But I have a video, and I was trying to get the sound to work, but I think in this room it doesn't work. So I'll just play it a couple times, and then you kind of just watch it, and then I'll sort of explain what's going on. Lots of people dancing, Pepsi. Okay, so this is a real life story that actually happened, and it's has to do with Pepsi and Coke, and you can see that the tagline is Pepsi now take the challenge. So this is called the Pepsi challenge. And so what happens is you can sort of see it here. What Pepsi decided to do is they decided to try and compete better with Coca-Cola. And so what they would do is they would go into real grocery stores and they would set up what they called the Pepsi challenge. And so the Pepsi challenge was a taste test. So they would give you 2 cups. One would have Pepsi in it, one would have Coke in it, and you can see that there's a screen here, and so you don't know which one's which. Okay, so the user in this case would sit there, they would take a sip of Pepsi, they take a sip of Coke, and what Pepsi was banking on is that users would say they like Pepsi better than Coke, and then when they reveal it, the user's sometimes surprised because they're like, well, I love Coke, I'm a Coke drinker, and then they remove it, and then, okay, so the reason, why was Pepsi doing this? The reason Pepsi was doing this is because they were actually destroying Coke in terms of this taste test. So everyone actually liked Pepsi better, or at least maybe not everyone, but like 80% of people or 90% of people would choose Pepsi in this type of test. Okay, so it was very, very effective. All right. Now, why do you think that is? If you've had Pepsi or Coke, do you have any reason why you think people might prefer Pepsi to Coke? Sweeter, yeah. Okay, so the main thing is it's significantly sweeter. Okay, and especially in a small amounts, you very quickly notice it. Or if you take them back to back. Okay, you drink the Pepsi, then maybe you drink the Coke, and you're like, oh, that tastes weird. It's not that sweet. Or you drink the Coke first, and then when you drink the Pepsi, you really taste the sugar. Okay, so that was basically more or less what it came down to. Now Coke was like, okay, it's actually hurting our business. This was a fun kind of gimmick from Pepsi, but now they're running ads on TV, and you could go to a local grocery store in Beaconsfield, Montreal, somewhere like that, and like actually do this Pepsi challenge. Like it wasn't something that they did 3 places in the world. It's like they were actually doing it in real stores, and so it was hurting Coke. So what Coke said is, okay, we have to respond, and so what they did is they went back to the lab and they started playing around with the recipe for Coca-Cola. And then as they were playing around with it, they were doing these user studies themselves, like not in a public setting, just within Coca-Cola itself. And they would tweak the recipe, and they were trying to find some recipe that would beat Pepsi at its own game. Okay? So eventually they did it. So they came out with Coke as opposed to Coca-Cola. And this is a new drink that was specifically engineered to win at the Pepsi Challenge. Okay. Then what Coke did is they actually discontinued the original Coca-Cola. So there was no more Coca-Cola. There was just Coke. Then what Coke did is they went into grocery stores and did the exact same thing as Pepsi. Okay. So they were like, okay, take the Coca-Cola challenge. All right. And they have the new Coke and they have Pepsi. And sure enough, they were right. People liked new Coke better than they liked Pepsi. All right. Why? Because it was even sweeter than Pepsi. Okay. It was very sweet. It had a kind of fresh, citrusy kind of flavor to it. And it just tastes different than than Pepsi, and it tasted better. Okay. So all of a sudden they were beating Pepsi at Pepsi's own game. Okay. But there was a problem. Okay. Here's the problem. The problem is people would go, they would do the challenge, and they would say, oh yeah, this new Coke is good. Let me buy a case of it, and I'll take it home. And everything was good until they drank an entire can of it, or they drank a couple cans of it. And then they realized, you know what, this is really sweet. And it kind of tastes like medicine. It's like got like that syrupy like kind of flavor. And yeah, when I had a sip of it, it tasted great. But now that I have a full can of it, I can't even finish the can, right? And so people hated it. Okay, they liked it in the taste test, but they hated it as a drink, and they didn't buy it. And Coke like suffered even more than they did before they did the taste test and re-engineered it. And so Coke had to very embarrassingly take this off the market. They went back to Coca-Cola, and they added the original Coca-Cola just to reinforce the idea that this is the old recipe. It's not this new Coke anymore. And even today, I think, actually I haven't looked recently, but when I was growing up, cans of Coke do say the original Coca-Cola on them, even though this was like in the 70s or something like that when they did this experiment. Okay, so what's the moral of the story? The moral of the story is that if you take a sip of something, right, you might have a different reaction than when you drink a lot of it. Okay? Security is kind of the same way. It's kind of a weird analogy. But when you think about like warnings and dialogues and things like that, the first time you see it, you're like, okay, that's good. It's helpful to me, right? You like the sip of it, but then once you've done it 100 times, you don't like it anymore. All right? So user studies are particularly bad because you only get a user for 30 minutes. So basically, you can just give them a sip of the software. And the way they feel after a sip might be very different than the way they feel after using it for a month, right? And all the little things that you put in to make it do well and perform well when they're spending 30 minutes with it might be super annoying to the users after using it for a month, okay? Another story about this, oh, by the way, this story is from this book, Blink. Another example of this is Clippy. I don't know if anyone remembers Clippy, but Clippy was added to Microsoft Word. And it's literally for a usability reason. Word processors are pretty complicated. People weren't super comfortable with them. You know, now you're native. You grew up with word processors, like they're the easiest piece of software you use, but that's because you've been using them ever since you've been using a computer, right? But you know, it wasn't always that way. People weren't always like computer native. And so it was like hard to like change fonts and change the paragraphs and change the justification. Like for a lot of people, they struggled with that. And so Microsoft said, okay, we're going to have this like little dancing paperclip that's going to ask you things, you know, like, do you want help with writing the letter or whatever? And you can see why this does good in a user study. You bring a user off the street, they've never used a word processor before. You tell them, write a letter. This thing jumps up and says, do you want me to help you write a letter? You're like, yes, I want you to help me write a letter. It's great, right? And so they're going to say, we really like this system. It's really good. Those are the kinds of results you're going to get out of a user study. But then after a week or a month, it's super annoying, right? It's like distracting you. You can't get rid of it. You can't put it away. It starts animating, you know, every now and then. It's asking you stuff and you're like, just shut up. Like, I just want to write my letter, right? And so it's the kind of thing that like gets annoying after a while, okay? So again, with usability, you have to think about the long term, not just the short term. Okay, so to try and correct that issue as well as some of the other issues, there's a third kind of usability study you can do, which is called a field study. A field study is that you actually give the system to your users and you let them use it for days, weeks, months, okay? And as they're using it, you're measuring different, whatever you want to measure about it. Maybe you're sending questionnaires to get qualitative data, but any quantitative data, you're just sort of reading out of it. So in order to do that, what you're going to do is you're going to have to not just have your system ready to go, but you have to have a data collection layer to your software as well. So it has to be a slightly more complicated version of your software to collect all of the data. And then you just give it to people and say, okay, this is your software now. And then you sit back and wait for the data to come in. Okay? And the nice thing about this is when people start to use it, they might be thinking about how this is a new system, but in a couple of days, in a week, they completely forget that like it's collecting, it's watching what they're doing or anything like that, and they just end up using it, and you can get really good data from it. So one study that's like kind of this nature was actually done by people in Montreal and Ottawa. So they at Polytechnique, they did this project where they literally gave people laptops. They said, we're doing a study. We want to understand how people get infected with malware. Okay? We can bring people into a lab for 30 minutes. No one's getting malware in 30 minutes, especially with someone like watching over your shoulder. But you give someone a laptop and say, this is yours. Do whatever you want with it. Whatever you're going to do with it, go do it. Go to the sketchy torrent sites, like whatever you want to do it. And the only thing is, though, that it's going to collect data automatically. It will be anonymized and will protect your privacy and things like that. But we're going to look at it. And sure enough, if you give someone 4 months with a laptop, a bunch of them are going to get malware. Okay? And you know now exactly what sites were they on, how did they do it, like were they doing their software updates and that type of thing. And then part of the study was they could bring the computer in and they would help them fix it and things like that. And so anyways, this is like a real field study, right? Like people are actually using the computer, and that's where you're going to get the best data from. Okay. The problem with this is it's expensive, right? You have to give people laptops and things like that. It's not like paying someone $20 for a user study, or it's not like a cognitive walkthrough where you just do it yourself and you don't have to pay anyone anything. Normally what you would do in a field study is, again, you do a sort of between subjects type of thing where you're not going to show the same thing to all your users. So you'll give half of the users, say, the new system, half of the users will continue using the old system. Sometimes this is called A/B testing, just means that people get A and some people get B. And then with A/B testing, the other thing that tends to happen is you sort of evolve your design. So this is an example where there's a learn more button, okay? And here it's blue, here it's green, and there's a little arrow icon before it. And if you show 10,000 people version A and you show 10,000 people version B, you can see how many people click on learn more, right? And you might notice that when it's blue, 52% of people click on it, and when it's green, 72% click on it. You don't know why. Who knows why? You know, people like green, it's easier to see, it catches the eye. I don't know why. I just try all the colors, and green's the one that comes out on top, so now I'm going to use green, okay? And then I might run it again, and I might like have the arrow or not have the arrow. And I might decide, oh, the arrow helps or it doesn't help, okay? So this is like how things work. So it's used a lot in like, if you do advertising, say on Google, you buy some AdWords. Google will do the A/B testing for you. They'll say, give us version A, so you'll write out your little ad, and then you can do version B. Maybe you change a word, or you write it slightly different. Then you tell Google, okay, it's good to go. You wait a week, and then you come back, and Google will say, well, 60% of people were clicking on version A, but only 40% were clicking on version B. And then you can tweak it again, and then you can rerun the ads. And they're just randomly picking whether to show you version A or version B. So anyways, this is another example of a field study. Okay, so field studies have very strong ecological validity. Ecological validity, again, is like, the user in the study, are they using it in their natural environment? Okay, so you bring someone into a lab in a university and you watch them use a system, that's not their natural environment. You give them a laptop, they take the laptop home, they've had it at home for 2 months, they're using it every day, they've forgotten about the fact that they're in a study, they're just using the laptop. Okay, so that's strong ecological validity. So that's the big benefit of a field study. Representativeness is how closely do the users in your study match your real users. Okay, if you're doing a field study, say in a company, you're literally going to give, say, the new version of the software to your actual employees. So your actual employees in the study are the same as your actual employees. Okay, so the people in your study and the people that you're writing the software for are exactly the same people. Okay, so the representativeness is perfect, or near perfect, because maybe you're choosing a random half of them. Okay, it's not like you have some students at a university in a study for some device that you want to deploy to elderly people. Okay, where the people in the study are different from the target user. With a field study, you can do, once the software is there and it's ready and it's instrumented, you can deploy it to 5 people or 100 people or however many people you have. Okay, it doesn't really cost more to give it to 200 people as opposed to 20 people. If it's purely software, maybe it depends a bit, but you can deploy it to a large set of users. You can sit back and wait for 4 months. And so all those subtle effects, like someone sipping the software, they don't like Clippy after a couple weeks, you'll learn all of those things. Okay, whereas if you bring them in for half an hour, you're not going to learn that. How much of the software are they going to use? You bring a user in for 30 minutes, you can ask them to do a couple tasks. They're not going to use every aspect of the software. But if you give it to them for 4 months and you have 100 users, one user somewhere in that group over that 4 months is going to use they're pretty much going to touch every part of the software that users might touch. So like different users will, like they'll play with the settings or whatever kind of weird things that your software does, at least one user is going to do it. So you're going to get good coverage of the whole software. And then you might also learn things from like you might have an expectation as to how you think users are going to use it, and then they end up using it in a completely different way. Okay? So this happens a lot. And then what you can do is you can actually change the software to make it better because you know how users want to use it, and you can see that they're not using it the way that you want to use it. Okay? So an example of it, this again, not a actual software example, a real life example, is this picture. What do you see in the picture? So there's a grass field, there's some building. What's going right down the middle of the field?
People like to walk on that direction.
Okay. So there's a path, we call it a wear path, okay? Because people walk there, right? Now, is there a sidewalk there? No, it's like through the grass, right? It's a dirt path. Is there a sidewalk on the external? You can't see it, but let's assume that there is, okay? So this is like how people design software. It's like, okay, we know users want to walk from building A to building B. We're going to put in a sidewalk. Okay, so you put in your sidewalk. Okay, then you sit back and you wait 6 months, and then you go and you see this. What does that tell you? It tells you you did your sidewalks wrong, right? Like users don't want to walk on your sidewalk. They want to walk, directly from building A to B. And if you're smart and you care about your users, what will you do? You'll put a sidewalk there. Okay. Now it's not always possible, right? Depends on, like specifically for wear paths, it's not always possible to put a sidewalk exactly where they are. But users are telling you something. They're telling you through their actions, right? How they use it is telling you information, and you could improve the usability to help the user if you wanted to. So this is sort of an analogy for the kind of data that you could get in a field study. Okay, what's the drawbacks of a field study? They're expensive. Okay, so you gotta, first off, it has to be a finished product. If you're doing cognitive walkthroughs or user studies, you can have a product that's half finished. You can fake things, like there's actually no database in the end. It's just like all manually entered or whatever. You just give them the user interface. But here you need the software needs to be done. On top of it, you need to instrument the software to do all the data collection and anonymize it and all of that type of stuff, okay? So it's not just that the software is completely done. It's like software plus this extra instrumentation needs to be done. And then the problem is if you give it to the real users, and let's say that it's horrible, right? Then you're hurting productivity of the company, because now the users are frustrated and they can't do their job as well and things like that, okay? So you're actually costing the company money indirectly by trying to do this like study with all the people. So before you do a field study, you really need to test it and make sure that like it's not going to be harmful at the end of the day in order to do it. Okay, so normally what you would do is you would actually do all three kinds of types. So you'll start with the cognitive walkthrough, you'll identify a bunch of issues, you'll try and fix them, and then when you feel good about it and comfortable, then you'll do a user study. And because in a user study you only have 30 minutes, you'll test the highest priority things. For the cognitive walkthrough, you'll be like, okay, I'm really concerned about these three things. Let's do a user study of just those three things. We're not going to try and test everything, okay? Then maybe you go back to the drawing board, you realize that one of them is actually a big issue, more than you thought. So you try and fix it, and then you do some cognitive walkthroughs of the fix. You're comfortable again, then you do a user study. Now it looks good. So then you do the field study and you actually deploy it, for example, okay? So that's like a long product, like a long development cycle. But that's the kind of thing that you would do if you were doing commercial software and it's expensive software and you have a big market share and things like that. You might not do that for something simple. It depends on exactly what you're doing. Okay, so that's all I wanted to say about usability. Questions about it? Yeah.
Yeah. We discussed about case study, survey, these titles in detail.
Yeah.
But I'm wondering about questions of this topic in the examination. Or we need to design a case study about the topic in the exam or something like that? or
Yeah.
we just answer the keywords?
Okay, so what kind of exam questions will I ask you? This is like something you can probably ask me after every lecture, because it's actually really hard to like write exam questions for this kind of thing. Okay, the types of questions, it will not be our keywords. It's not going to be like, give me the definition of X or give me the definition of Y. Remember, you have a cheat sheet, so you can write all your definitions and things like that. I could ask you to design something, but it tends to be time consuming for you in an exam, and it's also very time consuming for me to mark. So I tend not to ask those questions. There'll be a couple short answers that are more like kind of like a longer concept. So I could do some sort of usability, like write out 5 core tasks for this and what would you do for this? Like that will make more sense after next lecture. So it's possible. I'm not saying you won't see that type of question, but it is like, it's not the easiest questions to mark. And they don't do well. It's hard to answer those types of things in an exam setting. Anyways, those are the types of things you would see in an assignment as opposed, because then you can think about it and take it offline as opposed to an exam. So what's in the middle? So it's not going to be simple keywords. It's not going to be like design a whole user study. It's going to be something in the middle. So it could be like a multiple choice question, like usually I like scenario-based questions. So I'll be like, okay, Alice did a user study. This is what she found, you know, is it right? Is it wrong? Or she decides it's wrong. Is it wrong because of A or B or C? That kind of thing,
But
so.
in the scenario-based question, you usually see the best answer and better answer, you know what I'm saying?
Yeah. So all multiple choice, when I use multiple choice, will be select the best answer. So there isn't. I usually always try to make just one answer that's right. But sometimes students will argue, well, like in some weird circumstance, this other question is right, which is fine. But like this question is right 99% of the time. Sorry, this answer is right 99% of the time, and this other answer is true in 5% of the time. But so that's why I say, select the best answer. But yeah, usually it won't be like there's 3 actual right ones and, one's correct 99% of the time, the other ones are correct 80% of the time, and you have to try and figure out the difference between, 99 and 80%. It's not going to be like that. But I like scenario-based questions, or like, Alice did this user study and she realized that there was a mistake. Can she fix it or not? Yeah, she could fix it. She could just run more users through the study, or she can't fix it. It's too late, or she can, reword what she asked the users and then that would fix it, or, like those are the kinds of questions that I would ask. Yeah.
But still the answers changes depends on the user's perspective, right?
Yeah. I'll lock down a scenario so that there's only one right answer. Yeah. So that's on me to do in the question. It's not going to be like a vague sort of thing. Like I'll make like whatever if I'm asking about what's the mistake or something, like it will be clear. Or what's the fix? Like it will clearly match the scenario or whatever. But yeah, and it won't be like a half-page thing. It would just be like a paragraph of like just the essential parts. That's my general approach to exam questions. So you'll see that like we'll do entire lectures on like just ideas, and then yeah, you'll always have that kind of question.
Yeah, so in this scope of user study, we just assume that there's no disruptive participants. Like
you can assume there are. It depends on the study itself. So let's say that I'm doing between A and B. What I want is that there's some number of disruptive users, and the number in group A and number of group B are the same. Then they'll cancel out. Yeah. So that's my hope. So I'm not necessarily trying to eliminate them. I'm just trying to balance them so that they end up not tilting the scales in favor of A or B. But then I could also I could try and test like with the Likert scale, like asking the same question more once and things like that. Like if there's if I can put my finger on exactly the kind of behavior that I expect and I can actually do something about it, then I might try to get the study to exclude them from the data. So yeah, so I'm not saying I would just ignore it. I would do what I could to eliminate it, but then at the end of the day, I would just rely on randomness and random assignment to take care of the rest. Yeah.
Under evaluation framework, the focus criteria is only usability, deployment, and security. Are there anything aside from that?
On the end, sorry, what was the last part?
Is the focus criteria for evaluation framework is only usability, deployment, and security?
Yeah.
There's no other criteria apart from that?
So it depends, I guess. So the reason I did usability, deployability, security is because the paper that I based it on, which was the first paper to do an evaluation framework, that's what they chose to do. Okay. Now, since that paper, there's probably 100 papers that have been written, and they've done evaluation frameworks as well, and it tends to be pretty good. So I would say in 80-90% of those papers, they do the exact same three. But every now and then you'll pick up a paper. Sometimes they'll get rid of a category. Like, for example, let's say there's no users involved. It's just some pure system. Then maybe you drop usability. Sometimes I've seen like people are like, privacy is different than security. So now it's UDPS for privacy security, you know. So there are tweaks to it, but I would say that UDS does pretty good across the board. Yeah. It's a pretty versatile way of doing it, and it tends to include everything, but it's maybe not perfect. Okay, other questions?
So when we saw the example of Likert scale, when you mentioned about having multiple similar type questions,
Yeah.
so is there a fine line between too much and too less, like the Goldilocks zone between if you're asking a certain question too many times or too less, so the users don't catch on?
Yeah, it's, I don't know that you really care that the user catches on. If they catch on, it's fine. It's probably not going to change things, unless if it's like a user that's trying to be lazy, but like usually if the user's lazy, they don't care if they're caught or not, because it doesn't matter, right? Like they're getting paid anyways, like who cares, right? So you don't usually have users who are like trying to screw up your study, like answer in a way that you can't throw their data away, but would also screw the study up, right? So that's like a very rare thing that you wouldn't see. So generally you don't try and design against it. The big problem though that you have is that when you ask the same question more than once, it just adds to the length of the survey, right? So you would tend to do that only for the key questions. There's some questions that you care a lot about. Those are the ones that you're going to duplicate. But you don't want to do it to the extent that now your 20 questions is 60 questions, and now a lot more users are getting fatigued, right? So there is a Goldilocks kind of like right balance between the two. And I don't know exactly where it is. It's sort of an art as much of a science, but yeah. Okay, other questions? Okay, great. So next class, we will come back to the expert review. We will do a cognitive walkthrough of Tor together. And then at some point, like months from now, you will do that for your assignment too as well. So yeah. All right, well, I'll see you all next week.